Okay, this is going to be the 9.2 mole to gram to mole practice problem solution video. So I'm just going to work through all these problems, and again, hopefully this clarifies or assists you in this content. So let me get my pen here. All right. Sodium azide, Na(N3) is activated in an automobile airbag. Nitrogen gas and sodium are produced according to the following equation. There it is right there. If you are given moles of sodium azide, 0.5, what mass in grams of nitrogen would result? So the basic format is you're going to start with what you're given in moles, and then you're going to use the mole ratio to get to the other compound or element that you're trying to get to. And then you're going to multiply that by the molar mass of that unknown compound or element that you're trying to get to. So we're actually going to set up two conversion factors for these problems. Okay. So first step is this equation balanced? Yes, all the equations on this assignment were balanced. Okay. So I'm going to start with what I'm given. 0.5 mole of, I'm just going to stick it on here to try to save some space, NaN3. So I'm in moles, so I'm going to use the mole ratio. Now I am in NaN3, so that needs to go on the bottom. If I look at my chemical equation, NaN3 has a 2 in front of it. So that means 2 mole NaN3 goes here. What goes on top is the unknown that you're trying to get to, in this case, nitrogen. Okay? So I look at my chemical equation. I have a 3 here, so it's going to be 3 mole N2. Now in our previous section, if I was just trying to figure out moles of nitrogen gas, I would be done. I'd go 0.5 times 3 divided by 2, and I'd get my answer in moles, but I don't want my answer in moles. They want to know mass in grams. Okay? So I'm going to have to set up another conversion factor, and in this case, our NaN3 is going to cancel out. I'm in N2, so N2 is going to go on the bottom, and it's going to be 1 mole. Here we are going to use the molar mass of that compound or the element that you were looking at. So I have to find the molar mass of N2. So the molar mass of N2 is, I have nitrogen, 2 of them at 14.1. So 14.01, I meant to say 0.1, is 28.02 grams per mole. So that goes on top here. 28.02 grams of N2 are in 1 mole of N2. So now I'm just going to multiply across 0.5 times 3 divided by 2 times 28.02 divided by 1. You should get an answer somewhere around 28.015 grams of nitrogen gas. Okay? Do not worry about sig figs because you're not here. So that's how you do problem 1. Moving on to problem 2. Carborundum, SiC, is a hard substance made by combining silicon dioxide with coke. That's carbon, okay, not the drug, as follows. Silicon oxide plus 3 carbons, or coke, equals silicon, I guess it would be carborundum and carbon monoxide. So what mass of SiC is formed when you have 2 moles of carbon? Coke, right? So you start with what you're given. I have 2 moles of coke. I'm in moles. I'm going to set up my mole ratio. I'm in carbon. I go to my equation. I have a 3 in front of it. I am trying to get to SiC. So then I look. Where's SiC? There it is. It's going to have a 1. Now again, if I was just trying to figure out moles of SiC, I would be done. Just punch in a calculator. But I want to know mass in grams. So I have to set up one more conversion factor where I have to calculate the molar mass of SiC. So SiC, Si, silicon, if I look at my periodic table, is around 28.09, and I just have one C at 12.01, and I add these up together, about 40.1 grams per mole. So remember, my C's are going to cancel out. I'm in SiC, that's going to go on the bottom. It's just going to be 1 mole. It's always going to be 1 mole when you're doing the molar mass. My molar mass of SiC goes on top. Punch this in the calculator. 2 times 1 divided by 3 times 40.1. You should get an answer somewhere around 26.7 grams of SiC. Next problem, coal can be converted to methane gas by a process called coal gasification. The equation for the reaction is as follows. What mass in grams of carbon, so again, I'm trying to find mass of grams of carbon, is required to react with water to form 1 mole of CH4, methane gas. So I'm given 1 mole of methane gas, and I want to know how many grams of carbon I can get. So you start with what you're given. 1 mole CH4. I'm in moles. I've got to set up my mole ratio. Because I'm in CH4, that's going to go on the bottom. I look at my chemical equation to figure out what number goes in front of it. So in this case, 1 mole CH4. I'm trying to get to carbon. So I look here, 2 moles carbon. They want to know grams. So I have to set up one more conversion factor using the molar mass of carbon to get grams of carbon. So my CH4 is going to cancel out. I'm in moles of carbon. 1 mole of carbon goes on the bottom. The molar mass of carbon, if you look on the periodic table, is 12.01 grams. Punch this in. 1 times 2 divided by 1 times 12.01 gives you approximately 24.02 grams of carbon. So that is going from moles to grams of something. Now this next section is looking at grams to moles. If you're given grams, you've got to convert it to moles, use the mole ratio to get your answer. So chlorine gas can be produced commercially by passing an electric current through a concentrated solution of sodium chloride, which is brine, and they give you the equation. If brine contains 250 grams of sodium chloride, how many moles of Cl2 can be produced? So you're going to start with what you're given in this case, 250 grams of sodium chloride. Now I am in grams. So my next conversion factor is I need to convert grams to moles because the only way you can go from one element or a compound to another is through that mole ratio. That's why the mole ratio is so important. So I have to figure out the molar mass of NaCl. So because I didn't really give myself space, I'm just going to put NaCl over here. So Na on the periodic table, 22.99, Cl, 35.45. You add them up, you get approximately, you might have a different number than me, but 58.44. So that goes on the bottom because I am in grams. So 58.44 grams of NaCl go here. 1 mole of that goes on top. So if I were to weigh out or measure out 58.44 grams of sodium chloride, that means I have 1 mole of sodium chloride. Okay, I'm finally in moles, okay, because the grams are going to cancel out. And because I'm in moles, now I can use the mole ratio. So I'm in sodium chloride. I look here. So I'm going to put a 2 mole NaCl on the bottom here. I'm trying to get to chlorine gas. So I look at the equation, it's going to be 1. Now I can finally punch it in my calculator and get an answer. 250 divided by 58.44 times 1 divided by 2 moles of sodium chloride gives you approximately 2.135 or something. You can round up. So I'm just going to round up to 2.14 moles of Cl2. Now they want to know how many moles of hydrogen gas can be produced. So, first step, start with what you're given, 250 grams of sodium chloride. You're going to set up your conversion factor. You got to get to moles, so that way you can use the mole ratio to go from sodium chloride to hydrogen gas. Now the cool thing is, you kind of already did the work above. So you can copy that first conversion factor, where I'm given, 58.44 grams of NaCl is 1 mole of NaCl. Here is the mole ratio. So, sodium chloride, 2. NaCl. I'm trying to get to hydrogen gas, so I find it up here. There it is. Hey, it's also a 1. My answer. Approximately 2.14 moles of hydrogen gas. All right, final problem. I don't even know how to name that, but it's a treatment for some cancers. It is synthesized by this following reaction. How many moles of NH3 are needed to produce this chemical or this compound that's used in the treatment of cancer? So, you start with what you're given. In this case, you are given 30 grams of this compound. PT, Cl2, parentheses, NH3, parentheses, 2. Okay, our first step is we got to convert it to moles so we can use the mole ratio. And I was very mean and cruel to make you do this, but I'm sorry. So we have to figure out the molar mass of PtCl2NH3 2. So I'm gonna put this down here. PT. But check it out on the periodic table. I got one of them at 195.1. I got chlorine. I have 2 of them at 35.45. I have nitrogen. Now, don't forget this little 2 out here. Gotta distribute, right, Parker? Not factor, or FOIL. Distribute. So I actually have 2 nitrogens at 14.01. And then my final one is hydrogen. Again, distribute. 2 times 3 is 6. 6 of them at each 1.01, which gives me approximately, and I hope I did my math right, I did it a couple times, I got 300.08 grams per mole. So somewhere around there. So I just figured out the molar mass of PtCl2NH3 or NH3 So that goes on the bottom because I'm in grams. And grams have to go on the bottom so they can cancel out. So I write down here 300.08 grams of PtCl2 parentheses NH3 parentheses 2 because those grams are going to cancel out. This is 1 mole of PtCl2 parentheses NH3 parentheses 2. Okay, so if I were to weigh out 300.08 grams of this stuff, I would have a mole of it. So now I'm in moles, I can use the mole ratio. Finally, right? So I look here, it's going to be a 1. 1 mole of PtCl2 parentheses NH3 parentheses 2. And I'm trying to get to, in case you forgot, NH3. So I look at my chemical equation. I have a 2 in front there. 2 moles, NH3. Okay. Wow, these are really bad equal signs. I'm so sorry. Whew, finally ready to punch this in a calculator. 30 times 1 divided by 300.08. That's a really small number. Times 2. Makes it a little bit bigger, but not much. So your answer should be approximately somewhere around 0.199 or 0.2 moles of NH3. All right, so that is grams to moles and moles to grams, two-step conversion factors. If you think this was tough, hold on to your butts, right? Because the next one, we're actually going to use 3 conversion factors in our lesson when we go from grams of one substance to grams of another substance. But the nice thing is you're basically following the same steps. You're just going to take it one step further. So I hope, again, this was helpful. And yeah.